Lesson 2 is about the two different types of waves that you meet. And there are two types of waves, and all other waves can be said to be one or other of these, and they're called transverse or longitudinal. So the first one is transverse, and in a transverse wave, if you remember your definition, every part or particle in the wave moves perpendicular or at right angles. So another word we could put in there is perpendicular. It's a maths word to use, of course. It means at a right angle, perpendicular to the direction the energy or the wave is moving in. So we could put in wave there instead. And so therefore, we can see a transverse wave here. The direction of the energy movement is this way. So the energy is moving from here to here. And as the energy passes by, all the particles are moving up and down as the energy passes by. So of course that up and down movement is at a right angle to the direction that the energy or the wave itself is moving. And that's a transverse wave, and it always generally has this kind of a shape. The second kind of wave then is a longitudinal wave, and this time, instead of the particles moving at right angles or perpendicular to the direction energy is moving in, this time the particles move from side to side as the energy moves by, or the wave moves by. So we say every part or particle of the wave moves parallel to the direction the energy or the wave itself is moving in. And I'll just show you a picture of that on the next slide. Hopefully you'll be able to see it. I can see it hasn't come out too well. I'll just scan in a wee bit till you see. So if you can see there, this is a longitudinal wave shown on a slinky spring. And every part of the wave is moving from side to side as the wave itself is moving past. So all the particles are moving from side to side, and the direction that wave is moving itself is obviously in the same direction, so they're parallel to each other. Now, in a longitudinal wave, you get positions where the springs might be closer together, and those positions where the springs are closer together are called compressions. And then you would have another compression on over here a bit. There it is there. In between spaces where the springs are further apart, very strange word, it's called rarefaction. It's like fraction only without the R in here. From one compression to the next, I'll just scan out again, and I know you can't just really see the wave itself on the black part, but from the middle of one compression to the middle of the next, so that's one position where a particle is doing one thing and it's doing exactly the same thing over here, then that is a wavelength, if you remember your definition of wavelength. So in a longitudinal wave, the particles are moving parallel to the direction that the wave itself is moving in. Now we're going to define a few different types of waves. The first one is sound, and sound really is the main longitudinal wave that we know. I might do this in black so you can see it. So sound goes into the longitudinal box. Next one is light. Light is a transverse wave. Next one is ultrasound. So sound and ultrasound. Ultrasound is just sound with very, very high frequencies, and we'll say a wee bit more about that later on. Next one is microwaves. They're transverse waves. Water waves are also transverse waves. And ultraviolet, I'm just going to call it UV, you also know are transverse waves. So really the main example of a longitudinal wave is a sound wave, or ultrasound is just a higher frequency sound wave. And that's the one you learn. Everything else then is transverse. Last slide. When you speak to someone, you make a sound. Okay, so you make a sound. Sound, you know, is a longitudinal wave, and therefore the air vibrates as a longitudinal wave. Now you can't really see it here. There's actually an ear marked in somebody's ear. Okay, so when I speak to you in my class, you are hearing the sound of my voice, and that means the particles of air in between you and me are vibrating. As they vibrate, they collide with each other and they pass the sound on. So the direction that the energy is moving in is from me to you, and the direction the particles are moving in is also parallel to that. Now, you can see there are groups of air particles which are closer together, and so you've got a compression here, and in between where the particles are spaced out, you've got a rarefaction there.